Hello everyone. In this session, I'll be explaining a simple code to perform string comparison. So what exactly are we trying to do here? We have two labels here, string 1, string 2, associated with some string data. We have written DCB here, which is nothing but define constant byte, because each character of the string requires 1 byte of memory. And since strings are null terminated, we have written comma 0 here. Align here, make sure that the next instructions whichever will be written are word aligned, okay, so that we don't get any memory alignment issue because of the usage of DCB instruction here. So let's start here. Area is an assembler directive which defines a section of memory to store this particular information, which are nothing but instructions, hence we write code here. Okay, strcmp is the name given to that section of memory. Read only because we don't want any modification to happen to this particular information during runtime. Entry is an assembler directive which indicates where exactly execution should start. That is the very first label seen after the enter assembler directive is the position where execution starts. Here R0 and R1 are loaded with the address of label str1, str2, so that we obtain the address associated with our actual strings into register R0 and R1. Okay. Check is a label again. Okay, so what is happening here is R0 is nothing but a pointer to string 1. Fine. So as soon as you perform LDRB, which is nothing but load a byte of data from the address pointed by R0, that is this particular data is actually loaded and placed in register R2. Okay, A is the character in discussion. Its ASCII value will be loaded into register R2. Okay, and R0 address is incremented so that it can point to the very next character. What we are doing in the second step is the pointer to the second string is R1. Using the pointer, we are loading the first character A. Actually, it's not A which is moved, it's the ASCII value of A which is stored in register R3. Once this is done, R1 is incremented so that it can point to the very next character. This increment is done so that we can focus on the next character in the next loop. Once the ASCII of the first characters are obtained in register R2 and R3, we perform comparison, which internally performs subtraction between R2 and R3, and based on the result, the conditional flags of CPSR are updated. Once they are updated, we check if branch not equal. What is not equal to? We are checking if z equal to 0. If it's actually 0, it means these two characters are not equal. We will branch to this particular location which stores R4 as 0, and then we will stop execution because we from the first character only will know that the two strings considered here are not equal. If they are actually equal, we will check if R2 is equal to 0. Why is this done? We are considering the strings which are null terminated. If we have already reached the end of the string, the current character in consideration will be null character. This is where we should stop checking. Okay, so we'll check if R2 is 0, okay, which clearly means we have reached the end of the string. And if we actually reach the end of the string, we'll jump to label equal, which will store a value of R4 as 1. The reason is, in this particular code, we are using R4 as the flag which can either hold the value 1 or 0. Okay, if this holds a value 1, it means checking is complete and the strings in consideration are actually equal, and if it is 0, it means that the strings in consideration are not equal. Okay, that's what we are doing. And next, let's assume this is also not the case. Like in our current case, only first character is in consideration. Neither we have reached end of string nor these are different. Okay, so in that case, we'll branch back to check. And this particular loop continues so that each character is compared, okay, based on their positions. Once everything is done, all checking is done, arg4 will either have a value 1 or 0. That will determine whether these strings are equal or not equal. Okay, end indicates the end of source file. So now let me check if there are any errors here. No errors, so we'll move ahead. Okay, now let's see what are the addresses we should consider for string 1, string 2. So the address of string 1 is 34 and address of string 2 is 38. Okay, and the very first thing that we'll do is we'll load the very first data of string 1 and next we load the first data of string 2. Okay, and then we have even performed the comparison which updates the CPSR. Okay, as you can see, both these are equal, because of which Z flag is 1 and carry is 1. Okay, carry is 1 if borrow is not generated, and borrow is not generated as long as first value is not less than the second value. Fine. So now what we notice is Z flag is actually equal to 1, because of which this branch will not occur. Okay, then again we are checking if we have reached the end. No, we have not reached. This will make sure Z is 1 if R2 is actually equal to 0, but that's not the case, because of which this branch will not happen, and instead you will see looping happening here. Okay, so the next value is compared. Okay, and since they are also equal, again looping will continue. Okay, and same goes with the third data. But then since all three values are compared, the next value considered will be a null character, that is nothing but the 0. Since both R2, R3 have null character, okay, they are not equal is not true, but R2 is actually equal to 0, which will make sure the control will be branching to equal, and that stores R4 as 1. Okay, and we are jumping to stop be stop, which is an infinite loop. Now let me change this. Okay, let me write something like ARM1 and ARM7. Okay, are these two strings equal? No. So in that particular case, what should happen? So if you notice here, string 1 address will be 34, but string 2 address will be 39. Okay, so now if I perform the same task again, and if you check the memory, actually the first three characters are equal, just the last character is different. It's 31 here and 37. That is because it is ARM1 and ARM7. Okay, so until these three characters are compared, everything will be fine, but when 1 and 7 are compared, you will get to know these are not equal, so it will jump to this particular label and store the value R4 as 0. Let's see that happening. As you can see, it has jumped to not equal and R4 is stored as 0, and then it reaches an infinite loop. Okay, so this was the simple code for string comparison.